Hello, how are you? I hope that you are all fine even though we are facing a pandemic nowadays. This time, I have to report the topic that was given to me entitled Specific Heat Capacity. To further understand the concept of specific heat capacity, I will let you first think about this. The feeling of hot mango pie can burn your tongue while the crust will not when the pie has just been taken out from the oven. So imagine that you are in Jollibee and you order some hot mango pies and you eat one of those and you directly eat one of those. So there's a tendency that you can burn your tongue while you eat the mango pie because of the hot feeling inside it, even though the crust is not. So next, an aluminum foil covering can be peeled off with bare fingers right out of the oven, but be careful of the food beneath it. So these situations have something to do with the specific heat capacity. So let's discuss it further on the next slide. When energy is added to a system and there is no change in the kinetic or potential energy of the system, the temperature of the system usually rises. If the system consists of a sample of a substance, we find that the quantity of energy required to raise the temperature of a given mass of a substance by some amount varies from one substance to another. For example, the quantity of energy required to raise the temperature of 1 kilogram of water by 1 degree Celsius is 4,186 joules. But the quantity of energy required to raise the temperature of 1 kilogram of copper by 1 degree Celsius is only about 387 joules. In the discussion that follows, we shall use heat as an example of energy transfer, but keep in mind that the temperature of the system could be changed by means of any method of energy transfer. So let us define first the heat capacity. It is presented by the big letter C. So the heat capacity of a particular substance is the amount of energy that is required to raise the temperature by 1 degree Celsius. So from this definition, we see that if energy Q produces a change in temperature or the delta T of a sample, then we have this formula. Energy is equals to heat capacity multiplied to delta T or the change in temperature. Next, specific heat capacity that is presented by a small letter C. So it is the energy required to raise 1 gram of a substance by 1 degree Celsius. It is the heat capacity per unit mass. So therefore, we have this formula. Specific heat capacity in small letter C is equals to energy over mass multiplied by the changes in temperature. So here 1 gram. So specific heat capacity from this formula. So as you can see, the small letter C is a specific heat of a substance. Energy, the Q, energy absorbed or released, and the M stands for mass of sample in grams, and delta T, changes in temperature. Note that if you want to find the changes in temperature, you must subtract the final to initial, from final to initial. So common unit for specific heat capacity is joules per kilogram degree Celsius. So from this side, we have specific heat capacities of some solids and liquids. So as I have said a while ago, the water has 4,186 joules per kilogram degrees Celsius, and the copper has 387 joules per kilogram degrees Celsius. So this is their specific heat capacity, or small letter C. So let's take this illustration. Suppose we have 1 kilogram of water and 1 kilogram of oil. So we heat them both. So to make the water reach the same temperature as the oil, we would need to add twice the amount of heat. Because the greater a material's specific heat, the more energy must be added to a given mass of the material to cause a particular temperature change, because the water has a higher specific heat capacity than oil. Next question. This is for the people who are likely to go to beach for swimming. So, as you observe, which has a higher specific heat capacity, water or sand? Explain. So obviously, water has a greater heat capacity than sand. Water is much slower to warm in the heat of the sun and slower to cool at night. Sand's low heat capacity is shown by how quickly it warms in the morning and how quickly it cools at night. Affects local climates. So another example of this is water is a useful cooling system for some automobiles and engines, because water has a higher heat capacity. Example. I'm sorry for this, hindi po siya nasali sa animation. So example number 1. How much energy is required to heat 0.500 kg of water from 20 degrees Celsius to 80 degrees Celsius? Specific heat capacity of water is 4.186 joules per kilogram degrees Celsius. So given specific heat is 4.186 joules kilogram degrees Celsius per kilogram degrees Celsius, the mass is 0.500 kilogram. The initial temperature is 20 degrees Celsius and the final temperature is 80 degrees Celsius, and the required is the energy. So from this formula to this, because energy ang kailangan. So energy is equals to mass multiplied to specific heat and delta T, or the changes in temperature. So substitute all the given in this formula. So mass is 0.500 kilogram multiplied to the specific heat of water is 4.186 joules per kilogram degrees Celsius, and the changes in temperature from final temperature to initial temperature, which is 80 minus 20 degrees Celsius. Then 0.500 kilogram, again 4.186 joules per kilogram degrees Celsius, and the difference of these two temperature, which is 60 degrees Celsius. And the answer is, the energy now is 125.58 joules. If we convert it to kilojoule, we have this, 0.12558 kilojoules. So therefore, the 0.500 grams of water needs 125.58 joules, or 0.12558 kilojoule, to heat 20 degrees Celsius to 80 degrees Celsius of the water. So next example. In a half hour, a 65 kilogram jogger can generate 8.0 times 10 raised to 5 joules of heat. This heat is removed from the jogger's body by a variety of means, including body's own temperature regulating mechanisms. If the heat were not removed, how much would the jogger's body temperature increase? So given the specific heat is 3,500 joules per kilogram degrees Celsius. So this specific heat is based on the table that I have shown a while ago, the specific heat capacity of solids and liquids. Then the mass is 65 kg and the energy is 8.0 times 10 raised to 5 joules, and the required is the temperature changes. Celsius. Solution. Changes in temperature is equals to energy over specific heat multiplied to mass. Then substitute all the given. So we come up with this. Then cancel all the same unit. So ang naiwan is ang degree Celsius. So that is the temperature. And this is now the changes in temperature, 3.51 degrees Celsius. So the jogger's body temperature increases into 3.51 degrees Celsius. Let's move to our last example. A 25-gram metal ball is heated 200 degrees Celsius with 2,330 joules of energy. What is the specific heat of the metal? So we have the given. Mass is equal to 25 grams, or we convert it into kilogram. We have 0.025 kilogram. The energy is 2,330 joules, and the changes in temperature, we have 200 degrees Celsius. So the required now is the specific heat. So we have the solution. So from this formula, come up with this. So specific heat is equals to energy over mass multiplied to changes in temperature. So 230 joules over 0.025 kilogram multiplied to 200 degrees Celsius, we have this specific heat is 466 joules per kilogram degree Celsius. So therefore, the specific heat of metal is 466 joules kilogram degree Celsius. To sum it up, the specific heat capacity is essentially a measure of how thermally insensitive a substance is to addition of energy. The greater a material's specific heat, the more energy must be added to a given mass of a material to cause a particular temperature change. So that's all for this topic. I hope you guys get it. Keep safe and God bless.